This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Please, before we go further, kindly remember to like, share, subscribe, and click on notification button so that you can have more of my video. Thank you. Today, the topic we are taking is under vector, and then we are going to solve an exercise relating to vector equation. Now, let's see. Let's consider the Cartesian system, 2D system. Here, I have a point described by this vector. Then I have a directional vector D. Let's say I have a vector A at this point here. Let's call this line AP. Now we want to determine the vector equation of the straight line relating to this expression that we have here. Now this particular vector OA, let's name it as my A, and we want to assume that this particular direction vector D is parallel to the vector AP. Now if I want to move from that means if AP is parallel to OD, according to the relationship between parallel vector, recall that if vector A is going to be parallel to vector B, then that means A and B can be related to one another. If let's say this is B, this is A, the either of them, the A can be related to B with a scalar multiplication of B. So that means if vector AP that we have there is parallel to vector OD, it means that vector AP will be scalar multiplication of vector D. So that means anywhere we are seeing vector AP, we can equally put KD, where K is a scalar multiplication. But at times we can use this symbol for K. So I can write the same symbol like this. So that means vector AP is parallel to vector D by scalar multiplication. So this particular symbol I have here is a scalar multiplication. Now, to determine the vector equation of a line, this is how we are going to do it. Now, if you are moving from point O to P, it is described by vector R. So I'll write vector R is like from O to P. It seems now moving from O to A and A to P. So I have O to A plus A to P. O to A that I have on this board here is written with vector A. So instead of OA, I'll put vector A there. Then I have this vector, then plus vector AP is parallel to vector OD, which I've already explained that AP is a scalar multiplication of vector D. So instead of AP, I will put scalar multiplication of D. So the expression I have here is called vector equation of a straight line. So we should remember this in solving exercises as regard to vector equation of a straight line. Now we are going to take an exercise. I'm going to clean what I have here. I'm going to clean it up so that you can use this side of the board, to solve a problem. We have two problems here. The first one says show that vector R, which is 2 plus 3k 1 minus k, is a vector equation of a straight line. Then the second question says find the vector equation number 1, and secondly parametric equation of a line passing through the point -1, 2, 3 and parallel to the vector 3, 0, -1. Now let's start with the first question here. We are given this vector to show that is the vector equation of a straight line. we should remember at the back of our mind that the equation of the vector equation of a line is given as vector A plus scalar multiplication of a vector B. Now, this particular vector that we have here is similar to writing it as xy, and this one is similar to writing it as xi plus yj. This expression of a vector is called the column vector, and this expression I have here is a rectangular vector. So in a nutshell, this one is similar, is equivalent to this. So that means I can rewrite this one to be equivalent to this. In this case now, the x that we have here is the whole of this, and the y that we have here is the whole of this. So that means this particular vector r can be written, instead of x, we put 2 plus 3k. 2 plus 3k, then multiplying I. Then plus, instead of y, we put 1 minus k. That's 1 minus kj. Now, let's open this bracket. We are going to have 2i plus 3ik plus j minus jk. Now, if we take the term in k together, we can have something like 2i plus j, then plus 3i minus 3ik minus jk. So I can factorize this my k out. So I have 2i plus j plus k bracket 3i minus if I take it minus j. So if you compare this with the standard equation of the vectorial equation of a straight line, if you compare it together with a plus lambda d, we can see that these are similar. In this case now, what I have here can equally be written in a column form. So this one can be written as 2, 1, then plus k brackets. This one that we have here, that is a 3 minus j, can be written as 3 minus 1. So if you compare this one now, our a is 2, 1, lambda is this k, and this particular vector d is 3 minus 1. Therefore, the expression here is actually vector equation of a straight line. So this one is an exercise to question 1. Then the question 2 says, find the vector equation and then the parametric equation of a line passing through the point this and parallel to vector that. Now we know that the vector equation r is given as a plus lambda d, and the vector, we are told that the line pass through this particular vector. That means pass through this vector a, that is minus 1, 2, 3, then plus this vector product times this expression I have here, 3, 0, minus 1. So if I open this bracket, this one can be written as minus 1. All the one I'm having on top here are for I, followed by j, then followed by unit vector k. So what I'm going to have here now, before I put the unit vector, let me rewrite this the way it is first. Minus 1, 2, 3. Then multiply this one out. That's plus 3 times scalar multiplication. Then scalar multiplication times this one give us 0. This one times this one give us a minus scalar multiplication. So I can rewrite it as all the ones that are above are for the vector I. So this one is actually minus 1 plus 3 lambda vector I, then followed by 2 plus 0. 2 plus 0 is still 2. That is vector j. That's plus. Then for this one, it's going to be plus 3 minus lambda, then vector k. So if we open this bracket out, we can have a minus I plus 3I scalar multiplication plus 2j plus 3k minus this times lambda multiplication. So if you don't multiply, if you leave it in this format, this is actually the equation, the vector equation of that straight line, which can be written in column form like what I have here. So the question says we should find the parametric equation. If you look at what I have here, I have R, the vector equation, as minus 1 plus 3 lambda I plus 2j plus 3 minus lambda k. This is similar to having xi plus yj plus zk as a standard form of 3D vector. If you compare this to this, x go with this. Want to do parametric equation, please? Parametric equation of the vector equation. So that means my x now is equal to minus 1 plus 3 lambda. And then my y is equal to 2. And my z is equal to 3 minus lambda. So these are parametric equation. We can make this lambda so the formula and rewrite this as x plus 1 divided by 3 is equal to lambda, y is equal to 2, and then this one will be lambda is equal to 3 minus z. So these are the solution relating to vector equation. Please, before I go, do not forget to like, share, subscribe, and click on notification button to have more of my video. Have a nice day. Bye.